So today we're going to do section 4.6 and 4.7. We have used all the ways to prove triangles congruent. So we can do triangles are congruent by side, 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 angle, and angle, angle, side. Remember, there is no such thing as angle, side, side, or side, side, angle. Because remember, they spell it ugly way, right? So there's no such thing as side, side, angle, or angle, side, side. So now that we know all the ways that we can prove triangles congruent, we're going to learn today to show that certain pieces of triangles are congruent by using something called corresponding parts of congruent triangles are congruent. Okay? Now we're going to abbreviate that as a reason as CPCTC. CPCTC. So after you have proven triangles are congruent, you can say certain parts of those triangles, either angles or sides, are congruent by using CPCTC. Y'all say it, CPCTC. And that means corresponding parts of congruent triangles are congruent. That's what that means. So when you write that as a reason, that's what you're saying. Corresponding parts of congruent triangles are congruent. Okay? So, and it says right there, what's highlighted in blue is very important. You must prove that triangles are congruent first before you can say CPCTC. So you're going to have to use one of those 5 ways to say the triangles are congruent. And if so, then you can say either certain angles or certain sides are congruent using CPCTC. You should already written it. Sorry. There we go. Corresponding parts of congruent triangles are congruent. So this section, we're just going to do a couple proofs as examples. That's it. And I think y'all have one left in your proof packet that uses this. I told y'all to save it. I think it's like number 6, right? So I told y'all to save that one. And so after today, you will be able to do that one. All right. So this is a nice little picture. It looks like a boomerang. Y'all know what a boomerang is? Except they're not pointy. They have kind of a round curve thing. Why we got that? Like we don't need it. It's 66. All right, y'all copy all that information, please, for this proof. And we're going to set up our statements and reasons table, draw the picture. So we're using some information, and we want to prove that this segment QT is congruent to segment TS. Do you see how we have 2 triangles here? Okay? So before I can say those segments are congruent to each other, I'm going to say those triangles are congruent by one of those congruent theorems. And then I can say, because of CPCTC, then I can say those 2 segments are congruent. So you're going to prove the triangles are congruent first, and then you can say those 2 segments are congruent by CPCTC. All right? So that's kind of like the roadmap. So set up your statements and reasons table. And our first statements are our givens. So angle 1 is congruent to angle 2. That's really crooked. It's a little better. And angle RTQ is congruent to angle RTS. Now, are those marked yet on my picture? No, so let's mark them. Angle 1 is congruent to angle 2. And RTQ, which is this angle, is congruent to RTS, which is this angle. Sound effects are good, right? And those are given. Can I say anything else in that triangle is congruent to each other? those triangles? Yes. Do what? That's what I'm trying to prove. I can't say that. They didn't tell me that. I can't say it. That's what I'm trying to prove.
R and S is the same as Q and R.
What tells me I can say that? Huh? I can't say QR and RS because nothing tells me those are congruent. I can say RT is congruent to itself. Right? Y'all with me? They both share the side RT, so I can say that's congruent to itself by what property? Reflexive. I know it's been a while. Now let's see if we can say triangles are congruent. What do I have here? Angle. Angle. Side. Right? Is that a way I can prove congruence? It's also side angle angle, which is the same thing as angle angle side. Right? We just got to go in order. So yeah, I can say those triangles are congruent. Remember before we left, we did that worksheet on writing congruent statements? Right? So remember, you got to put them in order by the angles that's congruent to each other. So angle Q in the left triangle is congruent to which angle in the other one? S. And then angle T is congruent to angle T. And so that means R is congruent to angle R. Right? So we practiced this the other day. Remember that puzzle that had a sentence about a snake at the end? Y'all remember that? All right, now which way did we say those triangles are congruent to each other by? Angle, angle, side. So now that I have said those angles are congruent, now I can say, yes, QT is congruent to ST because don't they match up on the congruent statement? Yeah, so now I can say they're congruent because of CPCTC. So that's why we have to be careful writing our congruency statement for those triangles and putting the letters in the right order, because that's how things match up, and that's how you can prove it. So segment QT is congruent to segment ST because of CPCTC. So if you want to prove triangles congruent, you got to use one of these 5 ways. And if you want pieces of triangles congruent, then you use CPCTC. But you have to prove triangles are congruent using one of those 5 ways before you can say CPCTC. Corresponding parts of congruent triangles are congruent. So if we can say the triangles are congruent, we can say corresponding parts are congruent. Okay? And these proofs are not bad. They're just like what we did, except for one more step, CPCTC. Y'all ready to go to the next one? This one looks like a kite. So that's all we're doing in this section is going to be writing proofs. So I'm just going to give you some examples of doing some proofs. So write that, draw the picture, and you can go ahead and set it up, statements and reasons. All right, so what are my first statements? Segment GK bisects angle FKH. I wish you'd use different letters. Those are given. Now, what does bisect mean? Cut them exactly in half, right? That makes them congruent, doesn't it? So, okay, let's talk about one part. FGH. Angle FGH is this angle over here at G. You see that? Well, this segment, GK, cuts this angle in half. That makes them congruent, right? So, as a result, I can say this angle is congruent to this angle. Angle FGK is congruent to angle HGK, right? And that's because that's the definition of an angle bisector, right? That's what a bisector does. It cuts it exactly in half and makes it in two congruent parts. Okay, so not only did it do it to this angle, it also did it to this angle, right? FH or FKH. So angle K is also going to be split up. So this angle is going to be congruent to this angle down there. Y'all see that? Okay, so write that one down. Angle, and if you want to put them on the same step, because it's technically the same reason, right? So if you want to put them in two separate steps, you can. I'm just going to put them on the same step. So angle FKG is congruent to angle HKG. And that's still the definition of an angle bisector. They told me that segment bisected both of those angles. So now I have two pairs of congruent angles. You don't have to write definition of angle bisector twice. You have to write both of them separate things. They're different. If you wouldn't have been touching your phone, you'd know. Liar, I've already wrote it down. Documented. Every time I see somebody using a phone during my notes, I'm writing it down for the rest of the semester. Every time. It's not necessarily 3, but if it's excessive, I'm turning you in. Because I have not given anybody permission to use it during my notes. I don't decide punishment. All right, what else can I say about those two triangles? Say it again. Yeah, they share a side, so obviously that side's congruent to itself, right? Can't say that. That's what I'm trying to prove. Y'all are saying stuff that we can't say. All I can say is KG is congruent to itself because they're sharing that side. Okay? KG or GK, either one. Okay? KG is congruent to KG because of a property. I cannot say FK is congruent to HK. You don't have a reason to say it is. You cannot just say it because it looks like it. That's not a reason. Okay? You have to use a property or theorem. Do what? Say it again. Close. That's right.
Thank you. Pardon the interruption. This concerns a bus announcement. Any student from Raymer that rides 031 Mr. Bohatch, once you get to Raymer, it will be leaving school about 45 minutes late. You will leave here on time, but you'll be at Raymer for approximately 45 minutes before you leave back. That's Mr. Bohatch, 031.
All right, y'all listen. So she's correct. Now we can say those two triangles, the top one and the bottom, are congruent because look right here. You got these two angles are congruent. What's in between them? A side and then angles. Angle, side, angle. Y'all see that? The sides between the two angles that are congruent. So now I can say the triangles are congruent because of angle, side, angle. Now just make sure when you're writing your statement that you match up the angles to where they're congruent to each other. Okay? So on the top triangle, angle G is congruent to which one on the bottom triangle? They have the same number of arc marks.
H. F, G,
H has no arch marks.
K.
G! That has one little arc and that has one little arc, right? Right?
D, G, D something?
So angle G and angle G will be in the same location. It's what we did last Thursday. Yeah, I know it's been a week, y'all, but I cannot go back and reteach it just because it's been a week. We have to go and learn new things every single day in here. We cannot backtrack. All right. Now, angle K on the top triangle is congruent to which one on the bottom triangle? K. Because both triangles have a K, don't they? Now, on the top triangle, which one has to be congruent to the other one? F has to be congruent to H because they both are the only ones without any little arch marks, right? Right? Now, what reason did I say those triangles are congruent by? Angle, side angle. And now I'm trying to prove that FK is congruent to KH, and now I can say they are because why? Right, because now I know the triangles are congruent and their corresponding parts, because look, KF is in the same location as KH, right? So now I can say those segments are congruent. And they have them in the other order. It's the same thing. It's reflexive, right? Or not reflexive, metric. Because of corresponding parts of congruent triangles are congruent. CPCTC. Can I go? You good? One more of these, and then we'll go on to the next section. One more of these, and then we'll do one more section. Now, it didn't list out a given, did it? No, but it gave me a picture with some things marked, congruent, correct? Okay, so we're going to use our picture to get our givens. So sometimes they write the givens out for you, and sometimes they just give you a picture and say use the picture to prove, like this one does, okay? So if that's the case, use what is marked in the picture to get your givens. So that's what we're going to do. Statements and reasons. Oh, that's crooked, sorry. That's crooked too. Now, what all is marked congruent in this picture? Angle P is congruent to angle N. And what else is marked congruent? Segment NM in the top triangle is congruent to PQ in the bottom triangle. And all those are given. Right? And if you want to put parentheses from the picture. Yeah, that's angle L in the middle. And I don't like angles and L's. Y'all want to change that to a letter, another letter?
Can we change it to L?
Sure. Yeah, I don't like having L's for angle names because I use the little angle symbol. And mine look like L's. Okay. So, is there something else in my picture using an actual geometric reason to say that it's congruent to each other?
MS is congruent to PS.
Why can I say that?
Reflexive.
They're not the same thing, so you can't use reflexive property. Reflexive means something is congruent to itself. Say it again. They already said that. N and P are already given congruent in the picture. Do what? What geometric reason can I use to say that? You're just guessing. Y'all have to have a geometric reason to say something's congruent. It has to be the same thing congruent to itself. It has to be because we have the word midpoint or bisector. It had to be because of vertical angles or parallel lines and gave us all these angles congruent. We have to have a reason. We can't just say something's congruent because I want it to be or it looks like it. We have to have a geometric reason. Now, what's something in that picture? There's either one more pair of angles or one more pair of sides that I can say are congruent because of a geometric reason.
Are these all the recesses and these pictures that you
That and everything from chapters 1 through here we are. Anything we've learned in geometry can be a reason. But it has to be a geometric reason. Do what? Well, it's not congruent to itself, but this angle S up here is congruent to this angle S. There's two different angle S's. Y'all see that? Why can I say these two angle S's are congruent to each other? They're what? They're not the same. It's not the same angle. This is angle NSM, and this is angle PSQ. But why can I say they're congruent to each other?
Because the triangles are the same.
You don't know they are. You can't say triangles are the same. Not reflexive, because reflexive you have to use the exact same angle. They are vertical angles. I know, but you had other people say they're the same. No, they're not. This is an angle up here, and this is an angle down there. Y'all can't just say something's congruent because it looks it. You can't do that. But you got it, like vertical angles is a geometric reason. Y'all see what I'm saying? Y'all see that? And they're not, you just can't say angle S because there's 4 angle S's in this picture. Did y'all see that too? This is angle S, this is angle S, this is angle S, and this is angle S. So you got to name it. There's 3 different ones or 4 different ones. So you have to say it's angle MSM, N is congruent to angle PSQ. Because they are what relationship with each other? Vertical angles. Y'all got something you want to share with the class, guys? All right. So, now what do I have? Can I say my triangles are congruent now? Do I have enough information to say my triangles are congruent? Do I have one of those 5 reasons on the board to say triangles are congruent? Which one? How many sides and how many angles do I have marked? 2 angles and 1 side, right? Now, is the side inside the 2 angles or outside? Outside. So it's angle, angle, side. You see that? If it's between them, it's angle, side, angle. If it's outside them, it's angle, angle, side. Does that make sense? Okay. Triangle. Now we gotta say them congruent with congruent angles. So we got a top triangle and a bottom triangle. So tell me 2 angles in the top triangle that are congruent to each other. N and P. So I put them in the same spot. What else? S and S. And what else? M and Q are both not marked, so now that I can say they're congruent, I can put them in the same spot. And we said those triangles are congruent because of what? Angle, angle, side. So now LM and LQ. Oh, I meant to change those to S's. I'm so sorry. I didn't change them there. Forgive me, y'all. SM is congruent to SQ. SM and SQ are in corresponding corresponding locations, so I can say what? I wanted to write in red. Quit. Now, I can say segment SM is congruent to segment SQ because of why? CPCTC. Corresponding parts of congruent triangles are congruent.
So it's always going to end in that C.
If you're showing a part of the triangle, if you're showing the sides are congruent or the angles are congruent, you have to show that they're congruent first using one of those 5 ways. And after that, if they're specific pieces of triangles, then you can say they are because of CPCTC. But you have to prove triangles congruent first. And y'all can't just look at a picture and say, it looks like angle M is congruent to angle N. Or it looks like that whole triangle is congruent to the other one. You have to mathematically, geometrically prove it. Got it? Got it? That's why we have learned countless postulates, theorems, definitions, and everything else. Yes, sir.
But if side and M is congruent to PQ, why can't I just only say that M is congruent to PQ?
Because angles are not necessarily congruent just because segments are. Segments and angles are 2 totally different things. Because if you're talking about a segment, you're talking about a length of it. It could be 12 inches. But if you're talking about angles, you're talking about degrees. Totally different things. All right, well, that's the end of that section. Thankfully, that was kind of quick. Get out your handout for chapter 4. Okay. Get out your handout for chapter 4 and go ahead and start taking notes on section 4.7. Okay. All right, go ahead and start. Copy that first picture, but when you get to base angles theorem, that's on your handout. Okay? So copy the title, what an isosceles triangle looks like, and then when you get to base angles theorem, we're going to find it on our handout. In case you can't read that, that does not say 6G, it's his leg. It's his leg. I'm like, yeah, I know. I connect my L's and E's. I'll fix it. L-E-G, L-E-G. Is that better? A little bit? Okay, so we already talked about isosceles triangles a little bit before, right? They have 2 sides congruent. We learned that like the very beginning of this chapter, I think, when we first started talking about different triangles. Because remember, we had scalene triangles, when all the sides are different. If 2 sides are congruent, it's isosceles. If 3 sides are congruent, it's what? Y'all remember? Equal, lateral for sides, angles, equiangular for equal angles, right? Of all 2, if 2 sides are congruent, isosceles, 3 is equilateral, all right? So this is just about isosceles, and then we'll get into some equilaterals in a little bit. Now, what you need to know about isosceles, the 2 congruent sides are called legs, all right? So we got 2 congruent legs, and between the 2 legs is something called the vertex angle. So the angle between your 2 congruent sides of your isosceles triangle is called the vertex angle. The 2 angles at the ends of the legs the angles that are not between the 2 ones are called the base angles. Okay, so the ones kind of, they could be above it or below, just depends on how it's turned. Those are called base angles. Okay, so the vertex angle is the one between the two legs. The base angles are the ones that are not between the legs, the other two. Okay, so we got some theorems about isosceles triangles. Very back of that handout, if you still have it, hopefully. And you can mark these. The first one is the base angles theorem. These are nice little theorems that tell us some things are congruent to each other. So the base angles theorem says the two sides of a triangle are congruent, which makes it an isosceles triangle. So if we have two sides marked congruent, then base angles are congruent. So two sides are congruent in an isosceles triangle, and also two angles are congruent. So that's pretty cool. That gives us a lot of information. Okay, so the two sides are congruent, and the two base angles are congruent. Okay, so that's cool. That's a lot of information if we know it's an isosceles triangle. The converse theorem. Remember what a converse says? It reverses the hypothesis and the conclusion of a theorem, right? So the converse theorem says if two angles of a triangle are congruent, then the two sides are congruent. So if we have base angles congruent, then we have congruent sides, which makes it isosceles. So the first theorem said if we have an isosceles triangle, then base angles are congruent. Now we know if two angles are congruent, then those two sides are congruent. Okay? So remember, converse reverses the order. So if we know two angles are congruent, we know two sides are congruent. We know two sides are congruent, we know two angles are congruent. So here's a little example. It says in triangle DEF, DE is congruent to DF, and that's marked on the picture. So that makes this what kind of triangle? Isosceles. Two sides are congruent, so two sides are congruent. So it says name two congruent angles. Now, which angles are congruent in an isosceles triangle? They're called, they start with a B. The base angles, right? That means the two angles that are not the angle between the two lines, right? So angle D here is the vertex angle because it's between the two sides that are congruent. So that makes what two angles the base angles? Angle F and angle E. So you can say angle F is congruent to angle E. Because we know in an isosceles triangle, if two sides are congruent, then the two base angles are congruent. Okay, so the two base angles are the two angles that are not between those two congruent sides. You okay with that? So basically, the rest of the time is we're going to use some isosceles triangles to say different things are congruent. Now this says you try, but we're not you trying. We're just going to do it together. It's just practice. We're not you trying. We're doing together. 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 So number 1 and number 2 down here are using this same picture. And number 1's going to tell us two sides are congruent. So we're going to tell, because of that, what two angles are congruent. Okay? Yes, well, kind of. H is for both of them. K is for both of them. It's kind of off. Let me see if I can match up those letters. But yeah, it's purposely. These are not congruent triangles. That's not what we're doing here. Okay, they're not supposed to look congruent. What letter was here? I forgot. Was this H up here? And this is K? Okay. But yeah, they're not congruent triangles. They are two attached triangles and they share the side HK, but they're not congruent to each other. That's not what we're doing in this section. Okay? So I'm going to mark for this one, it says segment HG. HG is congruent to HK. They don't look it, do they? But it tells us they are, so they are. So that's why you cannot go by pictures. Pictures are not drawn to scale. Now, you guys are going to take the practice ACT on March 12th. That's just like 2 weeks from 2 days ago. All right? It's a week from this coming Thursday. ACT is notorious for drawing pictures, and they will say, picture not drawn to scale. That's why you cannot go by how something looks. All right? It don't look like this segment's congruent to this segment, right? Because like she said, they're drawn slanted on purpose. All right? So you just have to go by what they tell you and mark it. HG, I'll do it in blue, is congruent to HK, which makes that what kind of triangle? Isosceles. So because of that, I can say two angles are congruent, which would be the base angles of that triangle. I don't need this triangle, do I? I don't need this triangle for this problem. I just need this left side triangle. Now, what two angles are the base angles here? G and K. Because H is the vertex angle, it's between them, so the other two are the base angles, right? So I can say angle G is congruent. Does that make sense? Okay. Okay, number 2 is different. Number 2 tells us two angles are congruent. So let's mark those. Angle KHJ, which is this top angle, correct, is congruent to angle KJH, which is over here with angle J. Right? So those two angles are congruent. So if two angles are congruent in a triangle, then we know two sides are congruent, right? So what two sides would make these two the base angles of an isosceles triangle? Which sides would be congruent if those two are the base angles? I'm going to erase the blue stuff to keep us from being confused. So we're not using this left side triangle, right? We're using this triangle. Which two sides of that triangle would have to be congruent for those to be the base angles? Do what? Well, not HJ, because it's between them. HK with which one? KJ. Right? Right? Because K would be your vertex angle. Because if these two are the base angles, this has to be the vertex angle. So that means the two sides that make it isosceles would be off of that. Does that make that sense? Okay, so then we can say segment HK is congruent to KJ. Make sense? How we get good at stuff? Practice, practice, practice. Are these corollaries on there? Yes, they are. Very bottom of your handout. So that means these are our last theorems for chapter 4.
Did you say that test was
12th.
I'm not going to be here for 13th.
Your practice ACT will be the 12th. Your junior year. How are people oblivious to the world? It's just what I don't understand. Okay, so mark these on your handout. You don't have to copy these down. The corollary to the base angles theorem is okay, this is cool, y'all. If a triangle is equilateral, what does equilateral mean? All sides equal, then it is also equal angular. What does equal angular mean? All angles are equal. If it's equal angular, what do the measures have to be?
No, 45. No, 66. 60.
Well, all of them have to be, all three have to be what?
180.
180 divided by 40 is? I'm just calling out.
50. 55. No, wait, 60. 60. 60.
Okay, equal angular means all the same, right? 180 divided by 30 is what, Noah?
I was thinking that.
60. Yep, and then you add a 0. Good job. Okay, so if a triangle's equilateral, it's equal angular. The last one says if it's equilateral, then it's are equal angular, then it's equilateral. It goes both ways. Okay? If it's equilateral, then the angles have to be equal. If the angles are equal, then the legs have to be equal. All the sides have to be equal. Cool stuff. So now we know all our information. We'll look at this. You don't have to write this one down because y'all just tell me what it is. What kind of triangle is this? Equilateral, because it's showing three sides congruent. So that means we know that what?
All the angles are 60.
All the angles are congruent. Specifically, they're all how many degrees? 60 degrees. So the measure of angle P is 60 degrees. Now, if you're talking about measures, you have to say degrees, right? Measure of angle Q is 60 degrees, and the measure of angle R is 60 degrees. Not even worth writing down. Y'all got that, right? If it's equilateral, it's equal angular. What kind of triangle is this one? Isosceles. How do we know it's isosceles? Two angles are congruent. Now they tell me that angle Y is 50 degrees. But I've got to find the measure of angle X and angle Z. What do I know about the measures of angle X and angle Z? They all three have to be equal to 180. That's correct. That's important information I'm going to use in just a second. What else? What did we just learn about isosceles triangles? Base angles are congruent. Are X and Z base angles? Yes, because 50 is the angle between the two congruent sides. Right? So give them a variable. Let's just call them X. So, or let's use A, because we've already got X for a name. So A plus 50 equals 180, like Noah said. All three have to equal 180. Right? So A plus A is 2A. Plus 50 equals 180. Subtract 50. So 2A equals 130. Divide by 2. What do you get? 65 degrees. So they're 65 degrees apiece. So the measure of angle X is 65 degrees, and the measure of angle Z is 65 degrees. How could you check that? Add it and add 50 and make sure they equal 180. Y'all see how I did that? They had to be the same. Assign the variable. Set it equal to 180. Good job. Looky there. That's a fun picture. I'm going to let y'all draw that one for a second. Pay attention to the arc marks. Uh-oh, X disappeared from my paper. Let me find that darn problem. I'm sure I did not make it up. Come here, X. Where'd you go? Here, it's supposed to be X plus 1 right here. Sorry about that. I must have erased it. There's X. Got to find the value of X and Y. How many triangles do I have in the picture? Trick question, there's 3. The outside, the big one. Okay, but really, I'm gonna look at these 2 little ones. Okay, look at this one. What's cool about this one? It's equal angular, which means it's also equilateral, right? So if I know one of the 3 sides, I know all of the 3 sides, right? So this is 4, so that means Y has to be what? 4. And that means this one's also 4 too, isn't it? So go ahead and label all those. This is 4, and this is 4, and I can also say Y equals 4. That's in an equal angular triangle, which I know is also equilateral. All sides will be the same. If one side's 4, they're all 4. Does that make sense? That was nice and easy. Now I've got to find X. And X is this side right here. And it's just part of this bottom triangle. So I only need to look at this bottom triangle. What do I know about this bottom triangle? It's got 2 angles congruent, which means it has how many sides congruent? 2. If 2 angles congruent, base angles congruent means I have what kind of triangle? An isosceles. Now which 2 sides will be congruent? These 2, right? Because if these two are my base angles, this has to be my vertex angle. So that means these two sides that join up to the vertex angle have to be the congruent ones, right? So how do you think I can find x? Right. So basically I set them equal to each other, right? Since I know it's isosceles, this measure equals this measure. So like you said, but I'm going to set it up, x plus 1 equals 4. And then I can subtract 1 everywhere. X equals what number? 3. And you plug it in. 3 plus 1 is 4. Well, that side's 4. I just can't find this side down here, right? That one's still a mystery. But it's okay. I didn't have to find it. Y'all see how I got those, X and Y? Let's do another one. This one's similar. Oh, very similar. Super similar. What's it going to be easiest to find, X or Y? X. How can I find X so easily? It's equal angular, so it's equilateral. So if this side of this triangle is 7, what are all the other sides of that triangle? They got to be 7. So that means X is included in that. So X is also 7. Y'all see how I got X? That makes sense? If it's equal angular, then it's also equilateral. All right, so that means this triangle is what kind of triangle? Because it has 2 congruent angles, so it's isosceles. So that makes this the vertex angle. So what 2 sides are congruent? Yeah, the one that has a measure of 7 and the one that has a measure of y plus 4. So to find y, I say y plus 4 equals 7. Because this is an isosceles triangle. And so those 2 sides will be congruent. And you're right. Y plus 4 equals 7. Subtract 4 and y equals 30. Good stuff, right? Easy. Why can't geometry always be so easy, right? Right. Y'all want to just watch me on this last one? Kind of looks kind of junky. I don't know why my pen wrote fat there. I don't know what's up. Okay. This one I do have 2 triangles, right? Because together that makes some kind of weird looking quadrilateral. Now, I got a few things going on here. Together, these 2 angles right here make a 90-degree angle. Do y'all see that? I see that? I got a bunch of tick marks for sides. What kind of triangle is this one? So that means it's also what? Equal angular, which means all 3 vertices have to have angle measures of what? 60 degrees. We know that. If it's equilateral, equiangular, the angle measures are 60 degrees, right? So I know that. So X is one of those angle measures, isn't it? So what's the measure of angle X? 60 degrees. So X is 60 degrees. Now it's going to help me to fill all these in. 60 degrees, 60 degrees, and 60 degrees. Okay, that's cool. I need to find this angle measure. What kind of triangle is this left side triangle? It's isosceles. It has 2 congruent sides, which means it'll also have 2 congruent angles, right? Now, y is not one of those angles, is it? No, it's the vertex angle. So, but I can get, if I can get these 2 angles, can I get y by subtracting from 180? Yeah, what are they? How do you know they're 30? This is a whole 90-degree angle, and this part's 60, so this part has to be 30. If this is isosceles, then this angle also has to be 30. Correct? So there we go. This one's 30 degrees. This one's 30 degrees. Now, how are we going to get the measure of angle y? 30 plus 30 minus 180, right? I'll just say y plus 30 plus 30. What is 30 plus 30? So y plus 60 equals 180. Subtract from 60 from 180. Y equals what? 120 degrees. Good job. So any questions about any of that? All right, we're going to call this the end of the lesson. We did 2 sections today, section 4.6 and 4.7. Have a good day.